Okay, hi everyone. My name is Georgios, and I'm a part of the team that does some of the key company metric forecasting at Spotify. And today, I'll talk to you a little bit about the art and science that goes into that. I'll give you a brief overview of the actual scientific process that we do and some of the tools that we use. But then in the end, I'll also talk a little bit about the art part of how we can use human intuition to keep our forecasting models honest and be able to extract meaningful stories behind them. Okay. Spotify is a music streaming business, and you can sign up and stream any song that you want, either for free on an ad-supported tier or on a more premium ad-free experience for a monthly subscription fee. And forecasting is an important part of Spotify's business, and I would argue of many businesses, because it gives an insight of where the business is heading so that internally the executives and the appropriate people can make informed decisions about how to allocate their resources. And externally, the investors, both public and private, can make informed decisions about how to invest their money. This screenshot is from the latest public release of Spotify's financials. And one of the metrics that we will focus on this talk is this MAU number. MAU stands for monthly active user. Roughly speaking, those are the users who use the service, Spotify. So they streamed anything on Spotify in the past 30 days. MAU is generally a number that a variety of companies use to approximate their growth. Facebook uses that, Twitter uses that, and I'm sure many, many, many others. So in this talk, I'll give you a little bit of an idea of how we approach forecasting this number, and then we'll take it from there. Forecasting exercises for my team happens once every quarter, usually towards the end of the quarter, and we forecast for 2 years ahead. Sometimes even further, but 2 years is the normal. And we forecast that on a daily level. So for every day, we produce a number that represents our prediction for how many monthly active users we will have for that day. Before I go into the process and the plots and all of that, just an FYI that these are all randomly generated. No Spotify data is used. And the first part will be focused on how we forecast that aforementioned monthly active user number for existing markets. Roughly speaking, an existing market is a country where Spotify has launched publicly for at least a year. The idea behind that is that our models will have enough data to train on. If it's very short time, then there's just the forecasts are not. These methods that I'm going to talk about just kind of start failing, so we need different methods. And one of the key things that we use in our process is a Python package. It's actually both for Python and for R, called Prophet. Prophet was developed by a guy called Sean Taylor at Facebook and then open sourced. And we like Prophet because with minimal code and expertise, the 4 codes, the 4 lines on the left, you can produce a reliable forecast seen on the red line on the right. So if you want a reliable, first baseline model, Prophet is actually a pretty good way to go. And it's easy to download and install Prophet and take it from there. I'm going to keep this overview of the process pretty high level, but every now and then I'll try to sprinkle it in with a few interesting details. And one such detail is that when we do this forecasting process, we usually exclude the first 2 months of a new market's launch. The reason behind that is that the growth that you see in the first couple months is just extraordinarily high. It's just it's all lined up demand that gets satisfied immediately, and then once that happens, the growth can find its actual true rate of growth. So we exclude that. Back to Prophet. We like Prophet because it's also highly optimizable. So it has a variety of parameters that you can grid search or use your understanding of the data to tune in perfectly to improve your models and your forecasts. The main shortcoming for us is that we would like a more granular model. To Professor Kahneman's point is that we want a story. Just giving a number is most of the way there. And like at the end of the day, that's mostly that matters. But you want to be able to understand why are you overperforming? Why are you underperforming? What went wrong and what went right? So some of the things that we want to ask ourselves and our CFO wants to understand and our CEO wants to understand and our public investors want to understand is, did we overperform our forecast because we activated users better? Did we start retaining them better? Or something else? So because of that, this is like the core of the idea behind our main method is we see our MAU, monthly active users, as cohorts. And we say, OK, so given each given date, how many users became monthly active users that day? And we actually take it even further. For the sake of this example, let's not even take all monthly active users. Let's only take users. Let's call them activated registrations. So these are users that signed up for the platform today and activated. So you signed up for Spotify today and streamed something. Not all the users do that. Most of the users do that, but not everybody. So this is only a specific subset of monthly active users. And you already see where I'm going with this. We are breaking down this really large set and large number into smaller parts. So given this number of activated registrations today, we keep track of that number. How many users became activated registrations in the past up to today? 100 users today, maybe 110 yesterday, maybe 90 the day before. And once we do that, we then keep track of those cohorts individually. So out of the 100 users that became monthly active users by registering on the platform, let's say a year ago, how many of them remain monthly active users the day after, and the day after, and the day after, up to 2 to 3 years later? And once you do that exercise, you see these retention curves. They're also known as survival curves. We call them retention curves. And what you see here is that the height of each curve is how many users became activated registrations on each day. And then the curve itself represents how many of them basically didn't churn for every subsequent day. And you can plot that and plot that. The color coding there is just for each year, et cetera. It's just for better visualizations. Now, once you have these retention curves, you can start doing some interesting mathematical stuff with it. And some basic things that you can do is you can normalize them to 1 to 0 or to 0 to 100 and start studying it. Furthermore, one thing that you can do now is you can calculate the average retention curve. The idea behind that is this is your baseline prediction for how an arbitrary future cohort will retain. If I tell you that 2 years from now, 100 users will become activated registrations, I can predict as a baseline how many of those 100 users will be monthly active users 2 years and 1 month from now, based on this curve. An interesting tidbit here is that this is actually a very powerful tool that you can use at your disposal here, and that's weighing. So when I say the average, I think mostly I mean just the normal arithmetic average, but that doesn't have to be the case. In the spirit of a fast-changing world, if you have reasons to believe that your retention is improving or decreasing fast, and your future will be more reflective of your present than of your past, go ahead.
So the x-axis number of periods, is it in days?
So in this case, it's in weeks, but you can think of it either weeks or months. It's arbitrary on purpose. What was I saying? So yeah, when you're calculating this average, you can, if you have reasons to believe that your future is more similar to your current situation and less than 3 years ago, you can weigh those recent retention curves more heavier than old ones. That's actually a very powerful tool because it really can adjust to changing trends almost unsupervised, like by itself, if you have reasons to believe that things are changing. Another interesting tidbit here is that all these retention curves are non-increasing because once you have a cohort, people can only churn out of it. They can't enter it. If somebody churns out and reactivates, that's a different cohort based on the date that they reactivated. So an interesting mathematical fact here is that each curve is non-increasing, but if you just take the average, actually, because the curves have different lengths, the average might start being increasing. So there's like some very simple tricks that you can do to solve that, and we have done, and I'm happy to talk about that offline. Back to the cohorts. Now, we have all these observations for the historical cohorts, for the past ones. And using Python's fit, extrapolate, and curve fitting, or any other tool that you prefer, you can fit those curves and extrapolate them to the future. So for the retention of the past cohorts, with relatively simple techniques, you can predict their future retention. And that's, if the dotted vertical line is the forecast date, that's the retention of the past cohorts. Now, for the future, Prophet comes back into the picture here. And Prophet can train on the size of the cohorts of the past and can predict the sizes of the cohorts in the future, that blue line, right? So now, we have that size. Well, can we predict the retention? We actually already did with a baseline predictive model. And we can now apply that average retention curve to the sizes that Prophet gives us to predict their retention. And now we have all these cohorts, and for every day we have a prediction of how many of those users will be monthly active users. By bottoms up, summing that up, you get the numbers that you want. Notice here that you still use Prophet to predict a metric, but now the metric that you're predicting is a lower level. It's not the entire monthly active users. It's only a subset. So when the time comes that, again, you have over-forecasted or under-forecasted, you can go back and say, OK, did Prophet over-forecast this metric and not this, et cetera. An interesting tidbit here is that actually the last few of the retention curves don't have enough historical observations to be extrapolated because they just Python just cannot fit it. So you either have to come up with more advanced techniques, which we are exploring, or you can also apply the average retention curve to that as well. So you can predict that retention as well. And you have done this exercise for a subset of the monthly active users. You repeat this exercise for the other subsets. And again, bottoms up, you sum everything up. And now you have a monthly active user high-level number that is comprised by the sum of lower-level numbers. And again, when the higher metric is going up and down, you can break it down a little bit further and understand why is that happening. That's exactly the pros of this approach. The cons is that it can become very data engineering, complex and heavy pretty fast. And that's mainly because you're not only tracking numbers of users who are monthly active users every day, you need to keep track the individual users because for each cohort, if you have 100 users, you need to keep tracking those specific 100 users every day. And that's where scalability and data engineers come in handy, and I'm trying to be very good friends with my data engineers. So that was a little bit about the science that goes into our process and how we use Python or R and Prophet's time series forecasting and how we divide users into cohorts and predict their retentions. Let's talk a little bit about some of the more art part of that process, because about how we incorporate human intuition and human on-the-ground knowledge for those metrics to make the forecasting model better and more accurate, and to tell a better story. One way that you can incorporate that is by handling irregularities. No metric that you track over time will be smooth all the time. There are going to be ups and downs, bumps, you name it. You need to be able to understand what's happening and what are the available techniques that you can use to overcome a potentially bad forecasting situation. Here's a simple example. imagine that we see on the red actual data, we see a step change in the historical data. And we need to make a forecast for the future. Now, this step change might be because a huge marketing campaign launched, because a new product launched, maybe a new partnership that we did, or maybe Drake and Taylor Swift released their album on the same day. That's actually a good parenthesis here that as the forecasting team, we should be able to be aware of many local and global major events that are happening in the world, both internally for Spotify, so both to be able to have communication channels with our marketing teams and our strategy teams and our operations of like, hey, we are having this huge initiative, or we are launching trials that can increase this and that, but also externally. So as a good example here is, maybe you are fans of K-pop, maybe you're not, but a month ago or so, two huge K-pop groups, BTS and Blackpink, released their latest albums on the same day. And on that weekend, BTS also hosted SNL. Those are like huge, like a seismograph. These are events that can affect our metrics. And at the very least, we should be aware of why are we seeing the things that we are seeing, so that we know that, okay, that's what happened, not something else, something worse that we should be aware of. So back to the example here, if you were to use like a Prophet or any other Holt Winters or an ARIMA model, the model doesn't know. The model sees this bump and says, okay, yeah, okay, sure. At the middle of 2018, this happened. Hence, I can reasonably learn that probably at the end of 2019 or 2020, it will re-happen again. But we as humans know that that's probably not the case. So again, this is more of an art than a science, and two different teams might approach this differently. But here's one way that we can deal with that. If we have reasons to believe that after the step change, the rate of growth remained the same, so it really was simply a step change and nothing else, one thing that we can do is that perhaps we can take all the historical data and adjust them to the step change. And that will preserve the rate of growth. And it will actually preserve also things like seasonality, yearly, weekly, and all of that. And then you can apply your regular models into that new yellow line and get a much reasonable forecast here. So take a look at that, much more reasonable. Again, that's one way of dealing with that. Maybe your team has different and better ideas. And finally, before we ship any forecast to our stakeholders, let alone to the super high-level stakeholders such as the CFO, we should have confidence in it. Like we, as the forecasting team, first and foremost, should have confidence in it so we can sell it to our stakeholders. And one way that we do those robustness tests is by we never produce a single forecast. We always produce multiple models. So one of them could be Prophet, the other one could be like the cohort model, the third one could be Holt Winters, you name it. And then we compare them to each other. And if you see a situation that, like the plot on the left, where like 2, 3 models more or less agree with each other, that's a good confidence booster. Two different models independently reached out a similar prediction. We are pretty confident about that. If we see models diverging, like on the right, then that's a flag that we should investigate further. Why is one model performing like this, the other one performing like that? Which one is the right one? And some means towards that end is we go back to our local partners on the ground. If this is the forecast for Japan, we go to the Japan marketing team and say, hey, what is happening? What did you do? What is coming up? The other thing we do, and that's important again, both internally and externally, if you see huge differences between the forecast from the previous quarter to this quarter, that's something you need to understand why that is happening. It's not necessarily bad, but you should understand why that's happening. And towards that end, again, we compare each forecast that we have to the immediate previews for that country and understand if we see differences, are they justified in the data? And if we don't see differences, then that's robustness. But again, also, to that end, even if we don't see differences, we should get the opinions of our local stakeholders because maybe the future for the Spotify in Japan is very different than the past because they are about to launch a new product. We should know about that as well. Some of the learnings here that I can convey is weighing recent observations heavier than past observations is a very powerful tool that you can use in a variety of settings. Being aware of the environment that you're operating in is also very important, especially for forecast. You should be aware of what's happened and be aware of at least the major events that your company and competitors are planning for the future. Always compare multiple models. I will never feel confident in a single model. And find ways to quality assure your data. Some of the ways that we do that is, like I mentioned with multiple models, previous forecast, but also talk with your stakeholders. Again, the Taiwan Spotify market and the Japan Spotify market is very different than the US Spotify people. And the US folks are the ones that have more immediate communication, so maybe I'm more aware of what they're doing, but we should be aware of globally of what Spotify is doing. Some of the future work that both that my team, that our team is working on, I think roughly speaking, there's like two main ways, two main directions. One is around improving, getting those performance improvements in the actual code. One of them is, if you're familiar with grid search, I mentioned that Prophet can be, it has multiple parameters that can be tuned. You can write code to grid search, and that's a whole different story because even if you grid search, you need a human intuition and human understanding of what are the parameters, what are the range for each parameter. That's a whole different, technical story that I'm happy to talk offline. But also, that's another thing that you can squeeze the performance out of. And I mentioned how we calculate one average retention curve based on all the historical ones. That's not exactly true. We are exploring ways to calculate multiple retention curves, for example, based on the month that the user became a monthly active user. Maybe users who became MAU on January are fundamentally different than the users who became MAU on November. Maybe on January, it's mostly people who got it for a gift and retained worse or better. We don't know. But you can imagine a way where you create multiple ones, and you can go as deep as you're allowed. And the other thing is more or less on the actual techniques on the back end. On the front end, we want to explore better ways to explore and understand both historical trends and anomaly detection, both in the historical data and the predictions. If you see a prediction that is vastly different than what you expect, that should at least raise a flag of okay, take a look, what's happening. If a specific day, some metric jumps up or down, again, you should be alerted to that at the very least. Another thing that that's the final thing that I will mention, another thing that we are pretty excited and we want to explore that, and I think I've seen talks from other companies that they're exploring it as well, is this idea of a forecasting as a service. Because our team is primarily tasked with forecasting, 2-3 company key metrics. But in that process, we have developed expertise and a code base that can be reused for other metrics. For example, the free unit can ask, can we forecast free users? Can we forecast ad inventory? Can we forecast advertisers? Why does it have to be only users of the core product? And to that end, you can imagine a future where our team has developed a solution where any team or person from Spotify comes in and says, here's a CSV or an Excel sheet with my historical data for the metric that I care about, or even here's a SQL query that you can go and query because we are also pretty open with our data, and then just give me a forecast back. And we can give you the best available forecast across various train and test splits, across various models. We can, on the back end, we can test Prophet, we can test whole winters, we can test, you name it, even grid search, et cetera. So you can give almost like an array of options to the user and say, hey, do you just need a simple forecast? Because we can create that in 3 seconds. If you need the absolute best forecast that we can get, go grab a coffee. It will be ready within an hour or so after it runs all the possible tests. And I know for a fact that I've seen these amazing talks, and this Uber had a really interesting blog post about it. So go check that out if you want to learn more about that. This is our team, Warren, Michael, Kirti, Mahan, and myself. Thank you so much for your attention. I'm happy to discuss offline or answer any questions. Thank you. Let me know if there's time. No, I think we have 4 minutes. So yeah, go ahead.
Would you mind talking a little bit more about a comparison of cohorts, you say?
Say that again, sorry.
If you have two cohorts, I wouldn't do any comparison of how it will help with your future.
If you have two cohorts,
Yeah.
how you compare them to each other?
Yes, I just want to know. Curious about how you
So if you have multiple, if you have if you have hundreds of them, you compare them by taking the average and understanding, getting better understanding of how an arbitrary average cohort in the future will behave. If you have another thing that you can do is you can take the starting date of each cohort and say, okay, well, this one started in January, this one started in June. Are they retaining differently or not? I'm not sure if that's what you're looking for, but those are some of the things that you can, those are some of the insights that you can extract from those retention curves. Is that what you had in mind?
Okay.
Okay. Happy to talk more offline.
Okay. So I had a question regarding when you're plotting those retention curves, right? So you're just forecasting the number, right? These would be my MAUs
Yeah.
for whatever next 2 years.
Yeah.
But are you actually forecasting every user, whether this user is being churned or not?
So I think in the process, not every user, because we have to forecast the future as well. And for the future, we don't have a specific user, right? Even on the existing cohorts, at some point, up to today, we know exactly which users retained. But after that, we can only predict the number of the users who will retain, not the exact users.
You could also improve, right? Like if you know that this user, maybe this user has a higher chance of,
Yeah. Then you're talking about
then you can give some
Yeah.
campaigns or something for the users.
That's a completely separate. That's a different beast. It becomes a different story. But yes, you can do that, and that's more on the personalization team to come in and say, oh, this person is actually in high risk of churning out. Let's do something, right? But yeah, actually, that's a good example of if somebody were to do an initiative like that, we should know about that because that will fundamentally change our retention curves. So it's not our job to do it, but if they do it, we should know. Mm-hmm.
When you have to forecast globally,
Mm-hmm.
do you forecast individual geos and add up, or
Yes.
do you do it because you are adding up the error as well?
Yeah, that's true. That's a good point. We do forecast on a specific market. There is really you can forecast it globally because the data is just, you need that granularity for each country because the forecast and the trends within each country are just so different.
Can you add up for the global number?
You do, yeah. You add up, so then there is some error that might get add up. That's something that I don't have a good answer of how to deal with that right now. Oh, sorry. I guess I'll respect the
So
order.
for your product, a cohort based on time of entry or time of registration is very relevant. But that's not true for all industries, right? For something, it might be totally when I run a campaign or a sale. How would your model change? I know this might be another 2-hour talk. How would your model change if the cohort was not date-based, but some other metric-based? And do you use examples like that within Spotify?
I can't think of any from the top of my head. Maybe we can discuss offline. It's hard to imagine that for any type of customer that you have, wouldn't there be some sort of a timestamp of when they became a customer?
That might not be relevant, right? So if I'm a shopper,
That would be relevant. Every day you have the option of coming back and shopping or not, and you can see.
seasonal, right? I mean, you go to a mall on a Wednesday afternoon, it's dead.
That's fair. I think that's maybe the vanilla approach.
Memorial Day, all those days are much more important to me. I'm a flower seller. Mother's Day is the most important day for me. So my cohorts are very different.
Your cohorts, I don't think that the cohorts are different. I think that your importance is different. Let's talk about this more offline. I think that we can. I don't have a great answer from the top of my head, but I think it's an interesting discussion.
I'm curious how how Spotify uses these forecasts and whether or not that affects your approach or changes your approach in any way?
Yeah, so definitely it's a public company, so it uses it, to inform investors. And internally, I think we use it to each local partners. I believe they benchmark their performance against the forecast. So hey, this is like what we expect to see. If you're, if for in Indonesia, Japan, those folks who are responsible for the growth of those markets, benchmark it against that. And overall, if we see rate decelerating, accelerating, if it's accelerating, that's good, but we still need to understand why it's accelerating. We have had, we were fortunate enough to have situations like that where we were vastly overperforming the forecast, and we were like, is the forecast bad, or are we actually overperforming? So it's, understand the reasons behind that and double down if that's the decision, and definitely raise flags. So like if we are forecasting a very slow growth, that's something that we should take care of. The model building shouldn't, right? Because the forecast is the forecast. So if we are going, if the rate of growth is slowing or the numbers are going down, the job of the forecasting team is to accurately represent that. So I think it shouldn't.
So you talked about using additional models.
Let me know when we should stop. Yeah, okay.
Yeah, you talked about validating your models using other models. If you're going to run them all anyhow, have you thought about doing a meta-analysis to combine the results together?
Yeah. We have done that. I think that sometimes we have like ensemble models. We have taken the average of two models because there was like some sort of truth. Like one model was catching that, one model was catching something else, and we reduced the variance or the error by combining them. We don't do, that's not the norm, but sometimes we do that for extraordinary markets. Thank you so much, everybody.